Hello everyone, how are you? So today I'm gonna solve this problem, create binary tree from descriptions. So basically we are given one array, one 2D integer array, which is called description like this, and we have to construct the binary tree using this description. Okay, so I'll tell you how to do that. Let me draw by a diagram this thing. So for example, this is the 2D array description. So let's take one point. Okay, so this is one array inside it. So this first guy, okay, in this 2D array, the element first guy would be considered as the parent and this guy would be child. And this point will tell whether it is a left child or right child. So if this is 1, then that means this 15 would be left child of it. And if it is 0, then it would be the right child of it. So it would be something like, if we go to descript it, it would be something like 20. Okay, and because this is 1, so it would be left child of it, so this would be our 15 and so on. We have to construct this entire array in this way. So come to here, this is 0, right? So 0 and 17 would be right child of this 20, so we can make it this as right child and this value would be 20, right? Then we will again go here, we will go to 15. So here 50 would be the parent, 20 would be child, and 1, this is 1, so it would be left child. So what we can do here, we can just make a 50 node like this and we will make this 20 as the left child of it. Now come to here, see this is 0. Okay, so because this is 0, then 80 would be the right child of first guy 50, so then it would be something like this. This would be the right child of it. Now come to last one. So what is last? Last it is 1, right? So that means this 19 would be the left child of 80 because 1 indicates left and 0 indicates right. So this would be something like this. So now you can see we have finally constructed a binary tree. So this is all what we have to do, right? Using this description we have to construct this binary tree. Now this is what we have to do. I will tell you how we have to do it. Okay, so I'll tell you my approach. So guys, what would be our approach is, first of all, I have created one HashMap which is of type integer and TreeNode. Okay, and one set of integers. I'll tell you why do we need this. So first of all these values like 20, 15, 20, 17, all these values are basically has to become a node, right? In the final answer, this should be a node of a tree. Okay, so for that reason, what I'm doing, see here, we are traversing through this description and see here what we are doing. We are creating the tree node of corresponding values and we are storing in the HashMap like D0. So 20 would be the key and new tree node with 20 value would be the hash node here. Okay, so we will store it something like D0 would be 20, right? So this 20 and this will be stored with the node of 20. Okay, so you can consider a node value having the 20 as the value. Okay, so in this way we would be storing all of them, even for the child as well as the parent, right? And those whoever is the child here, like in this case 15, that we would keep on adding into the set. So let's do the dry run of it. So come to very first location, so 20, right? So we are here in this thing, right? We are using a for loop. Okay, so D0 would be the first value, so hm dot put 20, this would be 20 and node equal to 20, so 20 and node 20 would be our first value. Okay, and similarly for this guy, for the child also, it would be 15 and node 15, right? So we will store in the HashMap 15 and this would be n of 15. You can consider n means node. Okay, so this would be our second value. Now what we will do is we will check whether what is the D2. Okay, D2 is the this guy. Okay, so see here, if D2 equal to 1, that means this guy has to become left child. So I'm doing here hm dot get D0 dot left. So D0 we will get directly this node, right? Dot left equal to hm dot get D1. So D1 is stored here. So this guy would become now left child because this is 1. Okay, so you can consider that so far we are done something like this, 20 and left child with the 15. Okay, so we are done till here. Okay, now what we will do is, after doing this, we will put this child guy into this set because we need to find the parent as well. So all the child guy would be here except parent, correct? So we will use that thing later. Now come to second guy. So this is 2017. So 20 is already there, right? So we don't have to store again. Then 17 is new guy. So first of all, we have to store this 17. So 17 will go with node value as 17. Okay. Now what we will do, we will check what is the D2. So D2 is basically 0, right? So in this case, what it has to become? It has to become the right child of it. See here. If it is 0, then we will make it right child of it. So 20 right child 17. Okay. Now we will go to the third node, basically the third element of this array. So we are here. Now check here, 20 is already there, 50 is new. So we have to create this node inside our HashMap. So see here, this would be 50 and node would be N50, right? So we will take it N50. Now after doing this, we will check what is the D2. So can you check what is the D2? D2 is again 2. So that means it would be left child. So this 20, see here, 20 has to become the left child of 50. So this would be something like this, 50, and left child of it would become the this guy 20. Okay, so here first we added 15. In second iteration we would add 17 here. In third iteration, what is the child? Third iteration, it is 20 the child. So we will add this guy as well. Now come here to this guy. Okay, 50, 80 and 0. So 80 is new guy, 50 is already there. So we will create this 80 as well here. So it would be 80 and the N80, node 80 basically. It's as simple as that. So we have created node 80. Now who is the child here? Child is 80, right? So we will add this child 80 into the set. And here you can see this guy, third one, D2 is 0 basically. So that means this guy 80 has to become the right child of this 50. Okay, so we will make this guy as right child of it. Okay, now we are coming to the final one. So see here, 80 would be the parent, which is already there in the list in the HashMap. Now 19 is new guy. So first of all, we have to create this guy into our HashMap. So this guy would be 19 and N19. Okay, so N19. Now what it is? It is 1. So it should be left child, right? So this 19 has to become the left child of it. So this would be 19. Now we will add our this 19 is the child here, right? So we will add 19 as well. Okay, so finally what we have done, we have already made the references here, right? That who would be left child, who would be right child. Only thing is we have to find what is the parent here. Okay, so see here, all the nodes are there in HashMap and all the child nodes are there in the hashset, except parent. Parent is not here. So when we will traverse through this HashMap, so any guy who is not there in set, that should be parent, right? So let's say we are coming from here. So first of all, it is 20. Let's say we are traversing through. So is there 20? Yeah, 20 is there. So that means 20 is also not our parent. Now come to 15. So is 15 there? Yes, 15 is also there in child set. So 15 is also not parent. Come to 17. 17 is also there. So it is not the parent. 50. So 50 is not there, right? Everything is there. 80 is also there. 90 is also there. So only 50 is the value which doesn't exist here. That means 50 is not a child. That means 50 must be a parent. So we can return this guy. Whatever node value is there at 50, we can get this HM. We can return the HM dot get 50. So we can say whatever is not contained. So 50. So N50 would be our node, which would be become our parent. So that would be our answer. Okay. So I think this should be very clear for all of you. We are doing in O of n time complexity. So let me show you the corresponding code for it. So this is my code. You guys can see it. Let me expand it a bit more. So see here, this is as simple as that. I just created the HashMap and hashset, and now I am traversing through it. So see here, I am checking if this guy HashMap doesn't contain this node, D0 node, then we are creating and putting into HashMap. Similarly, I am also checking the second guy, because both of them we have to create and save into the HashMap, right? So child guy also I am checking and creating and adding into HashMap. Now here I am checking D2, basically the third value, right? Which will decide whether it is a left child or right child, this value. So I am checking here, if it is 1, then I am making it left child, that the D1. If it is a otherwise it would be 0, so then in that case I am making it right child. And then I am adding this guy into child set. This is a set. So child dot add d1. So d1 is basically the child, so I'm adding only the childs here. Okay, so when we will come out of it, I'm just creating one integer variable called answer. Now see here, I'm traversing through our HashMap values. Okay, so these values are TreeNode basically. So see here, if a child doesn't contains the x dot value, because x is the node, that means that is our answer. I'm directly returning this return x. Otherwise this will never execute. I'm just putting, because it will give error, right? So this will never run according to question test cases, but we have to fill it. Okay, so this would be my answer, and this is also not required answer because we are directly traversing through the nodes. So let me execute this code. Yeah, it is running fine. Let me try to submit it. Yeah, it is getting submitted. So thank you for watching the video, and if you guys have any concern, please make a comment over there. Thank you.